Hello grade 12. This is a solution to question 2a on page 313 on bond energies. So question 2a gives you this reaction, hydrogen cyanide. Hydrogen gas produces methanamine, and it's already balanced. Make sure to check that it is already balanced, and it is. So your first step in answering a question like this is actually to draw Lewis diagrams, because you're looking at Lewis structure diagrams, because you want to make sure that you've accounted for all the different kinds of bonds and also whether they're double or triple and so on. So let's go ahead and do that now. So here for hydrogen cyanide, this molecule looks like this. Right, so we have one carbon hydrogen bond and one carbon nitrogen with a triple bond here. Then we also have two hydrogen hydrogen bonds. And for our product, the structure looks like this. Okay, so we have three carbon hydrogen bonds, one carbon nitrogen, and two nitrogen hydrogen bonds. So this is the Lewis structure needed, and we're going to make reference to that when we solve this problem. Okay, the other thing we have to look up, and it says, I believe it's on page 307 of your textbook, it's a table of bond energies. And these bond energies we are going to write down now, but you can just refer back to that table. In a test quiz exam, this type of information would be included either in a table or within the question itself. Okay, again, you don't have to memorize these. So referring to the table, we see that a carbon-hydrogen bond requires 413 kilojoules per mole to break. And I'll just continue writing the rest of them here. Okay, and carbon nitrogen is 305 kilojoules per mole. Okay, nitrogen hydrogen is 391 kilojoules per mole. So that's it. That concludes all of the different values for the different kinds of bonds. Let's scroll down a bit. Now, to calculate enthalpy using bond energies, we need to find the sum of our bonds broken minus the sum of our bonds formed. Okay, and these, of course, relate to, these are our reactants, and these are our products. Okay, and we have to account for how many moles we have of each of those different kinds of bonds. So let's continue. We're doing our reactants first. In our reactants, we have 1 mole. D represents bond energy, so 1 mole of a carbon or hydrogen carbon bond. Right, going back up to our equation here, we have 1 mole, that's this right here. That's one of those bonds. Oops. We have 1 mole of a carbon triple bound to a nitrogen. 2 moles of your hydrogen bonds. And that concludes your reactants. Okay, square brackets around that. We're going to subtract all the bonds formed. Here we have 3 moles of our carbon hydrogen bonds, right, from that methyl part of the amine. So right here we have 1, 2, 3. And since we're here, we have 1 carbon nitrogen, and we have 1, 2 nitrogen hydrogen. Okay, plus 1 mole of that carbon nitrogen and 2 moles of that nitrogen hydrogen. So I think that may have been the hardest part. All we do now is we substitute, place all of these values where they correspond, and you can do the math. So here we have 1 mole. Eight, 9, 1. Okay, so long step, but not too difficult. All you're doing is substituting. Notice units cancel out. Moles cancels throughout. Just canceling all of those. Right, and you should end up with, for your reactants, 2,168 kilojoules, right, minus your products, 2,326 kilojoules, and you end up with negative 158 kilojoules. And that is your final answer. Hope this helps.